Chapter 10, Human Alteration of the Atmosphere, Section 10.3, Industrial and Photochemical Smog. Little evidence exists to suggest that humans were responsible for air pollution prior to the Industrial Revolution. The creation of air pollution seems to coincide with the Industrial Revolution and our use of fossil fuels like coal, oil, and gas to generate energy, to be used for space heating, cooking, and transportation. Under the right conditions, the smoke and sulfur dioxide produced from the burning of coal can combine with moisture in fog to create industrial smog. And this industrial smog is essentially sulfuric acid droplets suspended in the atmosphere. In 1952, an industrial smog event in London claimed about 4,000 human lives due to respiratory effects. So as modeled here, what we require for the development of industrial smog, which is rich in sulfuric acid, is the atmosphere being high in humidity or actual fog existing, and the release of sulfur dioxide gas from the burning of coal. Industrial smog events are now rare in North America and in Western Europe. Industrial smog is still a problem in Eastern Europe, China, and India. In these countries, coal is still used to generate energy to run the economies of these nations. The picture on the right shows an industrial smog event in Beijing, China. Beijing, China has a particularly bad industrial smog problem. The image on the left shows what a clear sky condition looks like in Beijing. Photochemical smog is a different kind of smog. It has a different chemistry associated with it from industrial smog. Photochemical smog develops when primary pollutants that include oxides of nitrogen and volatile organic compounds chemically react under the influence of solar radiation, so you need sunlight. Development of photochemical smog is typically associated with specific climate conditions, usually areas of the world where high pressure systems dominate during some part of the season, and you need high population densities to produce the oxides of nitrogen from burning oil and the volatile organic compounds that also come from fossil fuels. Many cities with high population densities experience photochemical smog. Some cities that have it particularly bad include Los Angeles, Sydney, Mexico City, Beijing, and even Vancouver. So how does its photochemical smog form? It begins in the early morning when traffic increases emissions of nitrous oxides and volatile organic compounds. And these occur as people drive to work. By late morning, traffic dies down, and the nitrogen oxides and volatile organic compounds begin to react to form nitrogen dioxide. As sunlight becomes more intense, with the increase in the height of the sun, the nitrogen dioxide is decomposed and produces ozone. At the same time, some of the nitrogen dioxide can react with volatile organic compounds to produce toxic compounds known as peroxycyl nitrate, PAN. When sun sets, chemical production of ozone stops. The ozone in the atmosphere is then converted back into harmless molecular oxygen by several different chemical reactions. So here in our table, we can see the major toxic chemical elements of photochemical smog. So nitrogen oxides, NO and NO2, where the sources are, the environmental effects, and some notes about it. Volatile organic compounds come from evaporation of solvents, evaporation of fuels. Every time you fill your tank with gas, there's a release of volatile organic compounds into the atmosphere. They also occur naturally, and locations that have a lot of pine or spruce trees have particular problems where natural VOCs are released from these trees, and they're released from chemicals the trees produce called terpenes. Ozone is formed by the photoliths of NO2, so it's powered by sunlight. Peroxidal nitrates, or PAN, formed by the reaction of NO2 with VOCs. And you can see some of the environmental effects that these chemicals have. This diagram shows the chemical reaction involved, the major players, VOCs, nitrogen oxide, and PANs and ozone. And you can see photochemical smog in the air, usually from a high vantage point. Looking down into a city, you'll see that the air appears yellowy brown. So here's a picture of Los Angeles with an obvious photochemical smog event occurring.